webinar. The topic of today's webinar is Smart and Sustainable Mobility. My name is Sarah Moritpur, and in today's webinar, I'm just moderating the session. Before starting today's webinar, I would like to make the acknowledgement of country. We would like to acknowledge the Australian Aboriginal and Torres Strait Islanders people as the first inhabitants of the nation and the traditional custodians of the land where we live, learn, and work. We pay our respects to elders, past, present, and emerging. We acknowledge and respect the Treaty, Waitangi, and Maori as the original people of the New Zealand. Today's webinar is brought by the Institute of Transportation Engineers Australia and New Zealand section. We are an international membership association for transport professionals, and all the transport professionals who work to improve the mobility and safety and accessibility in all aspects of transport systems, and help build and provide smarter and more livable communities. We have more than 17,000 members in over 75 countries. And of course, as always, all new members are welcome. ITE-ANZ is sponsored by our wonderful organizations, Austraffic, Traffic Works, Sidra Solutions, Traffics Group, Lindsay Oxlade Consulting, and also Movement and Place Consulting are among our sponsors, and they are great in sponsoring our events, President Dinner, Student Awards, Postgrad Awards, Annual Breakfast, and also the Young Professional Awards and student chapters that we are running in different universities. In today's webinar, we are pleased to have Professor Hossein Dia as our presenter. He's the professor of Future Urban Mobility at Swinburne University of Technology, and he kindly agreed to join us in today's webinar and talk to us about sustainability and smart transport. Before passing over to Hossein to start his presentation, I would like to go through a couple of housekeeping issues. You will be automatically muted at the start of the webinar. And also, if there is any technical problem, please send a message via chat. The question and answers will be run after the end of the presentation, and please enter your questions for the presenter through questions and answers and not chat. As the moderator, I will go through all the questions and chats provided through question and answer section. I will read it at the end of the presentation, and Hossein will kindly answer your questions. Thank you very much. And I will pass it over to Hossein to start his presentation. Thank you.
Thank you, Sarah, and thank you for the introduction as well. ITE holds a special place in my heart. I've been a member since I was studying in the US. When was that? Some 40 years ago. And it's always great to catch up with colleagues and friends. So thank you for the opportunity to join you and your members today as well. So what I thought I would present today is talk about how AI can help us in shaping smart and sustainable transport systems. Also from my side, and before we start, I would like to acknowledge the Wurundjeri people of the Kulin Nation, who are the traditional owners of the land on which Swinburne's Australian campuses are located. And on behalf of Swinburne University of Technology, I pay my respects to their elders, past, present, and emerging, and hope that the path towards reconciliation continues to be shared and embraced. So AI is undoubtedly one of the most profound scientific developments in recent years, and we are already starting to feel its impacts in all aspects of our life. And what I'm hoping I would be able to achieve with you today is to go through the changing landscape of urban transport and see how we can frame AI within a smart mobility ecosystem, and then take you through some of the applications that we are starting to see. Some of it is in research phases, others are implemented, but mainly road safety, congestion management, um, applications of machine vision for detection of objects, people, cars, transport modes, etc. And of course, I think we cannot talk about AI without talking about connected and automated vehicles, autonomous vehicles in the future, and also without talking about personal mobility and the impact of things like Chat GPT and the natural language processing, how all of that is going to have a role to play in the future. I will conclude with some of the challenges that AI poses and look at how we can overcome some of these barriers. So one of the key advantages of AI is that it will help us to solve some of the transport challenges, particularly those persistent problems that we have been tackling for the past, half century with limited success. So we have a very good understanding, I think, about the impacts of urbanization, the impacts of lack of road safety, if you like, the road crashes and injuries, traffic congestion. We had a short reprieve during the pandemic when during lockdowns, we did not see a lot of traffic congestion, but as you can see now, the traffic is back and even in a more aggressive way than before in some cases. We have a good understanding about the impact of aging infrastructure, limited construction budgets, and in more recent years as well, we have started to look at how do we make our transport systems more resilient. Talking, for example, about how we saw a decline in public transport usage during the pandemic. But there are few issues that we don't seem to have tackled as well. These include emissions from transport, the energy provision from transport as well, and the impact, air quality and impacts on public health, and of course, the impact of climate change. Now, for a long time, we argued and we knew that transport and emissions have an impact on climate change. But in recent years, we have also started to look at how does climate change impact transport, impact where we live, impact where we work, etc., etc. So I would like maybe just to touch base on where we are on a couple of these things. So clearly, transport is a big source of emissions. In Australia, it is the third largest source of greenhouse gases, and it's accounting for around 19% of all national emissions. And according to the latest available figures, transport accounted for around 25% of all the energy consumption in Australia. Now, how are we doing in terms of targeting net zero? Well, all indications are we are way off track, if you like. If we talk about vehicle electrification, for example, we started very late compared to other countries. I think now, on average, I think it is 8% of all new vehicle sales are electric vehicles compared to 20 and 30% in other markets. There is also, in addition to the greenhouse gases, transport also is responsible for deterioration of air quality. And in some cases, even if we replace our vehicle fleet tomorrow from petrol and diesel to electric vehicles, some of the non-exhaust emissions, which cause a lot of harm, are still going to be there. So as you can see in this slide, in 2015, more people died from vehicle exhaust emissions in Australia than people who died because of road crashes. So I think slowly now we are turning our attention to these persistent problems. And we are hoping, of course, that AI and digitalization and transport technologies would help us bridge this gap and put us back on target. As I mentioned about climate change as well, and essentially it is the impact on resilience. So how do we design our systems? What do we do to make them smarter so that we can mitigate the impacts of these more frequent and more intense weather events that we have been witnessing, not only in Australia, but in other countries around the world as well. Now, fortunately, things are changing to the better, although maybe not at a pace that we would like it. The conventional approaches to transport have been to build out of congestion, focus on motorized transport, looking at private car ownership, and so forth. In more recent times, the interventions have been focusing around sustainability, looking at managing the demand for travel, um, making our roads and infrastructure for the movement of people and goods, not only private vehicles, looking at low carbon and low emission transport. And I think the one area that is a focus of my research is the role of digital innovations and transport technologies in actually addressing some of these problems and challenges. Also, okay, so if we look at how we treat technology in our transport systems, as you can see there is a sweet spot where we have the intersection, if you like, of infrastructure, users, and technology. This is where we bring together these elements to provide meaningful infrastructure, meaningful technologies that can help to address a lot of the challenges and essentially make the travel experience more efficient and more pleasant for travelers. Now, in more recent years, I would say maybe over the past 5-6 years, there's been a focus on smart mobility as well, and looking beyond ITS to look at what are some of the emerging trends, such as vehicle automation, vehicle electrification, Internet of Things. This is a big impact. All these sensors that we are installing in our cities are coming together now to provide a wealth of information. The sharing economy and how that has impacted car ownership. Now we're starting to look at urban air mobility and so forth. And I think going into the future, this whole platform, if you like, or framework is going to be underpinned by a new ecosystem where artificial intelligence is going to make everything a smart connected device, whether it is a bus, whether it is using an e-scooter, etc., to have a holistic look and a holistic environment where everything can contribute to efficiency, sustainability, and so forth. I think it is important as well to acknowledge from the start is that digitalization and automation are essentially outcomes that we implement based on our policy objectives and needs. So technology, we don't provide an automated vehicle because we think it is a cool technology. There is a big policy objective behind it, which is in many cases safety. So each of these technologies I showed, it needs to be part of a holistic approach where we say, these are our policies and objectives as a community, as a nation. We're looking at sustainability, we're looking at personal mobility and traveler well-being, economic viability, etc. These are the sectors that are serving it. They all need to be served by a digitalization and automation ecosystem. And then once we do this, how do we achieve those outcomes at the end? So technology, if someone comes to you and says, I have this piece of technology, it's great. You need to think about how it fits within this overall framework and whether it will contribute to these outcomes or not. All right, so let's have a look at AI now. And as I mentioned, it is one of the most profound developments in recent years, and is going to have a big impact in transport. So we talk about it, consider it as an extension of the digitalization that we have been doing, and it is going to provide a lot of advantages going forward. So probably you're going to find 101 definitions for AI, and this is 102 and 3 and 4. But essentially, what I try to do here is just to say some of the keywords. So they are computer systems that can be on your device, they can be on our computers, in our vehicles, that are both autonomous and adaptive. And other way to look at it is that they are systems that basically mimic how human brains function and mimic human behavior as well. Another way to look at it as well is that they are providing a layer of intelligence, where intelligence means autonomy and foresight, the ability to learn and adapt to a situation, as it develops and as it grows. So there are many fields in AI and topics, and I just listed here a few that we are starting to see their impact in transport. So there is machine learning. So on the diagram on the right, there's computer science, and part of computer science is AI, part of AI is machine learning, and part of machine learning is deep learning. So machine learning is really getting computers to learn without explicit programming. They are trained to recognize patterns from data, etc. Deep learning is a significant subset of machine learning, where we can use neural networks with multiple layers to process data. In recent years, we have seen the impact of natural language processing, like, for example, GPT, which is one of the really most advanced NLPs. There is also computer vision. There is the collaborative autonomous systems. In transport, these are the connected and automated vehicles that we have been talking about. And there is robotics, and in our case, it is the autonomous and automated vehicles. Now, AI has been around for a long time. In 1997, I did my PhD using neural networks for detection of accidents, or automatic detection of accidents. But then there was a lull, if you like. But in recent years, probably the last 10 years, there have been some significant breakthroughs that ignited the interest in AI again. So there are the machine learning algorithms and techniques, such as the supervised and unsupervised learning. There is the deep learning, which I think we owe a lot of the developments in autonomous vehicles for it, because it has transformed computer vision. There is the natural language processing advancements. And of course, there is the high-speed computing and its integration with IoT. I think most of us agree that the smartphone we hold in our hands today has the power of a computer, or maybe 20 computers 10 years or 20 or 30 years ago. So just to give you an example, just to demystify what is a neural network. So for example, let's say we want to predict travel time along a section of motorway. So on the right there, you see the physical road system, and we have our loop detectors that provide the information. And then we have the neural network model that can analyze the data, and it can predict travel time, for example, at a certain point in time. So essentially, they're like, those of you who work with regression models, they are a little bit similar, but clearly much more sophisticated. They don't work on equations. They work by detection of patterns and recognition of patterns. So let's look at some of the AI applications in transport, and starting with road safety. So probably, this is not new. Devices or cameras inside our vehicles that can help us with detection of fatigue. It can alert the driver in case, they're not taking a mandatory rest especially for truck drivers, for example. If people are being distracted, etc., all of these, I think we have them in many cars nowadays and many trucks and vehicles, but they have been enhanced through advances in machine learning. This is another example, a model where if we collect a lot of information from IoT devices, like you see here, for example, temperature, wind speed, visibility, the road width, speed limit, etc. In this particular project by Esri, they looked at a large number of data, 7 years of data. They used it to develop crash risk assessment models, where they can run the model and on a certain day in the future, they can estimate based on, for example, the traffic speeds, based on the number of vehicles on the road, what are the risks of having accidents in certain places. There is a number of projects around the world where they're looking at learning from crashes and also learning from near misses at intersections, collecting this information to train a neural network or to train a model to identify, for example, what are the factors that can lead to a potential crash. This will help to redesign those intersections that are at risk, or also use the knowledge when designing new intersections so that you can avoid the factors or overcome the factors that can lead to crashes. Congestion management. This is a case study we did a couple of years back using the in-telematics data. And we looked at Hodel Street. We looked at using the in-telematics data, which was really quality data, to predict speed and traffic volumes, up to 60 minutes into the future. So we got hold of around 10,000 observations, speed, flow, etc. Usually you divide these into a training data set and a validation data set. We developed an AI model or a neural network model that we have been developing for a while. We ran the data through it and we were able to look at the predictions up to 60 minutes. So as you can see there, these neural network models were able to predict with almost like 99% accuracy for speeds. And at the bottom there, you see what is the actual and the predicted speeds. And we did the same for traffic volumes. We looked at traffic flows. The prediction is a little bit lower, but still it's quite significant and it's quite high. So this means, this is giving a computer system the ability to predict what's going to happen up to 60 minutes into the future. This can be integrated into a digital app. It can be integrated with other devices. You might say, oh, well, what's the big deal? We have Google Maps, etc. True. Google Maps tells you, I'm leaving now. What are the traffic conditions? What this particular model does, it says, I'm not ready. I'm still having breakfast. I'm not ready to leave now. I would like to leave in 30, 45 minutes. Tell me what are the conditions going to be then. So this is where the advantage of this additional layer of prediction. Another case study, recently we got hold of MyKey data for Melbourne, and we used it to essentially predict the demand for public transport along certain bus stops and along certain routes. So we had quite a large data set, data from 18 bus routes. The input into these models was the passenger demand for each route and each bus stop, and the output was to estimate the demand up to 60 minutes into the future. Another model that we looked at as well was to, based on the day of the year, the hour of the day, the origin and destination, to be able to estimate what is the future demand or number of passengers that are going to be traveling between each of the origin destination pairs. And again, if you ask me, if we did this 20 years ago, would we have achieved a similar accuracy and prediction? Probably not. but this has been enabled with AI. Now, this is probably one of the areas where we're going to see major impact with machine vision. So these are a couple of examples of studies we have been doing with road agencies. This particular one, you know, when you have a rail replacement buses, a number of agencies wanted to find out whether these buses are being utilized well, you know, how many passengers are using them, etc. They had very crude methods. So we have been working on machine vision, very, you know, low-cost cameras that are supplemented with AI to actually try to answer some of these questions, as you can see here. This is another example where we, probably those of you who are familiar with Hawthorne would recognize this in front of Swinburne University. But here we were looking at pedestrian counting and also measurement of the degree of crowdedness in a certain place, like this example here, for example, in near Swinburne as well. During the pandemic, we did this study for the local council. They were looking to see, you know, if we can estimate, if we can use their cameras, and these are their cameras, again, very low cost cameras, to see if we can arrive at proximity estimation, you know, what is the distance between people, is it very crowded, and so forth. This is not a project we're doing, but we are embarking on something similar for freight origin destination. So we're rolling out a network of low-cost cameras across a study area in Melbourne, where we want to estimate freight origin destination just by computer vision. And I think you can see now that all of this is really building a smart infrastructure where, you know, we're putting a lot of IoT devices, adding that layer of intelligence on top of it that will enable us to have, you know, to be able to predict when certain elements of the road infrastructure might fail, bridges, etc. You know, we can put all the sensors, and you can use AI to train a model to actually start to predict these based on, you know, the vehicle load, the number of vehicles passing, etc. And clearly, one of the big advantages of this is that it will lead to cost reductions. I mean, if we, like the traditional approach where we are building out of congestion, if we are lucky, we might end up with a benefit cost ratio of 3. You know, for every dollar invested to build a tunnel, if we are lucky, you might get 3 on average. But you can see some of these technology-based solutions, you get much larger benefit to cost ratio, which means better utilization of taxpayer money as well. Now, connected and automated vehicles, clearly, you know, this is a big topic. It has been for the past 5-6 years as well. Today, we have level 1 and level 2 autonomy, if you like. Probably Tesla is level 2. The robo-taxis you see running experiments or trials in the US, these are probably at level 4. But we are not there yet with the level 5 or full automation. So today, a lot of our vehicles that are on the market actually have some of these driver assist systems, you know, a blind spot detection, lane change assist, etc. And what an autonomous vehicle does, or a highly automated vehicle does, is that you overlay more detectors, particularly cameras, if you like, and then you have the AI layer as well. You know, they're very sophisticated. They're, as you can see, computer the size of a lunchbox that goes into the trunk of the vehicle to make it really very, very smart to be able to avoid obstacles, etc. So this is how a self-driving deep neural network learns, or this is what, so it is shown millions of images, millions of situations where it can basically then start to recognize that based on this image I see, this is going to be my reaction, or this is the action I need to do. Now, the impact is going to be huge. We have already started to look at this. We've done some studies for Melbourne. And I mean, just to, very briefly, we modeled a nightmare scenario and an ideal scenario. The nightmare scenario is where each of us would have a small driverless vehicle pod where we travel, and that is a nightmare because it means the Monash freeway needs to go 3 times its current size, etc. Nightmare. The ideal use of these vehicles in the future is a form of public transport, particularly in the outer suburbs, where they can shuttle people from their homes to the nearest train station, and then you have that mass transit shuttling people into the city, into work, etc. But if we end up with those scenarios where we have these small, tiny vehicles with occupancy of 1 or 0 in some cases, if they're running around empty, that's going to ruin things in the future. Another question that a lot of people are trying to tackle is how safe do they need to be before we allow them on our roads? So we have some trials happening in the US particularly, where they have the robo-taxis. And as you can see with some of these images, they're still running into problems. So for example, in the lower left image, and probably you've seen it on social media, the autonomous vehicle or level 4 vehicle crashed into the back of a bus. It recognized the front of the bus, but it hasn't been trained on articulated buses. So this was a 2-section bus. So as soon as it saw the front section move, it started to move and it crashed into the rear end section of the articulated bus. The one on the right, an autonomous vehicle gets into wet cement. You might say this might happen to a human driver, possibly so as well. But what the studies are showing is that there are a lot of edge cases where these deep learning, even as sophisticated as it is, it's not making things much better. Another example is probably if an autonomous vehicle today sees a person wearing a yellow chicken suit, it might not recognize what it is, because these are not things we see every day. Okay, so if the deep neural network has not been trained on many images and instances of this particular image, it might not recognize it, and then bad things could happen. Now, again, we cannot talk about AI without talking about Chat GPT. So there are many applications actually where this can be useful, and essentially for personal travel. So they can provide customer support when people need to buy a ticket or need to book something, personalized route planning and navigation for people to suit their own. Again, you might say, Google does this for me, but this is going to be a step higher, if you like, and step more accurate. Multilingual communications. I mean, we've all been through it, going to a foreign country, and if you don't speak the language, it's very difficult to find or catch public transport. So all of these things can, something like NLP can make this easier. But there are big challenges with AI, and there are many ethical questions as well. And there are really 3 levels of concerns. The first one is bias. So as we said before, if the data set does not reflect the main population, then there will be a certain set of bias. As you can see here, that the driverless vehicle might struggle to identify or avoid certain sections of society. They need to be fair as well. So it is not fair, for example, if someone trains a neural network on images like these for people who do not exist, okay? It might build bias and unfairness. So this is something we need to look at as well. And the most important one is that when the AI model behaves in a bad way, and I'll show you some examples in a minute here. But I think the key to this is diversity. Need to train on a large number of data sets. Need to have a lot of people doing the training, because all of these data sets need to be annotated, and someone says, this is a child, this is a dog, etc., etc. And also need to have a variety and diversity of models. So the one particular area where AI might behave in a not very honorable way is when we look at this moral dilemma of autonomous driving. So MIT, few years back, they did a study, the moral machine experiment, where they asked people to provide, their answers. What would they do in situations that are edge cases, if you like? The likelihood of these situations happen is probably quite low. However, they might happen, and therefore they need to be addressed. So, for example, if a car, autonomous vehicle, something happens and a crash is to happen, does it sacrifice the passengers or does it sacrifice people on the road? Does it basically spare humans versus animals? Does it spare men versus women, etc.? So it was quite a big experiment, though. So they received, millions of decisions from a large number of people. Interestingly, there was strong agreement that we should focus on sparing humans over animals, sparing more lives, and sparing young lives. However, those moral choices were not universal. The study divided the responses into three categories or clusters: Western, Eastern, and Southern. And this is where it was interesting to see the results. So, for example, in the Eastern cluster, they had less pronounced preference for saving younger people's lives compared to older people. In the Eastern cluster, they had a preference for sparing higher status people, for example. In the Southern cluster, there was a preference for sparing or saving women and fit people over other road users. So that's interesting. And it will, that's going to pose a big challenge for how you design AI self-driving in vehicles for different regions in the world as well. And finally, as well, one of the big questions is who dictates these rules? We don't want a situation where car manufacturers can decide these rules. This is something that we, as a community, as a society, need to consider. And then some people are saying these self-driving vehicles on the roads, they're getting into accidents, etc., etc. Should they be allowed to go on the roads? And the industry so far has been self-regulating. There's a lot of studies now to look at, how do we verify that an AI self-driving software is ready to be deployed for pilot studies. These pilot studies should not be about testing the safety. The safety should have been done before, and this is only to basically, demonstrate feasibility, etc. Using Chat GPT, some ethical questions there as well. At Swinburne, for example, we encourage our students to use it, but there is an ethical framework. They cannot, for example, use Chat GPT or give it information from surveys they have done or confidential information, etc. Because all of us are using Chat GPT and we give it information, but sometimes probably we don't know how this information is going to be used. And importantly, there needs to be transparency in that essentially the customer needs to know in advance that, for example, if they are interacting with a chatbot, that they are actually interacting with an AI, not a real human, and they should be given the opportunity, if they prefer, to actually talk to a real human. Finally, I would like to talk about AI and the impacts on transport jobs. We recently, last year actually, we finished a study for the iMove CRC. You can see the full report, it's on their website. But we looked at which sectors that are likely to be impacted by AI. And I'm about to finish, maybe just a couple of minutes, and I'll be done. And we looked at some of these sectors. So transport, there is 39% chance, 39% of the transport activities are likely to be impacted by automation. We looked at which parts of we looked at which sectors are likely to be impacted. Drivers are going to be impacted the most. And we're already, as you can see in this video here, we're already starting to see examples of automation replacing drivers. The good story there, I think, is that automation, if I can bring here, I think although automation is going to replace some jobs, technology will eliminate jobs, it will not eliminate work. So, for example, we identified this study where it was found, even though there's going to be a large loss by 2034 of large number of drivers, for example, especially truck drivers, the technology and advancements are going to require new jobs to be created. There's going to be a net negative balance, but it's not going to eliminate all jobs. It's going to create more as well. So in terms of going forward, I think this needs to be tackled at the national level, part of a digital transformation of transport. We did another study 2 years ago where we developed an index of best practice digitalization and automation. Australia was ranked 13 out of all OECD nations. You can see Korea, Japan, Netherlands, even the US and Switzerland. These were some of the top countries. There's a lot of learnings that can be obtained from these nations. We have proposed a national summit to look at this, but AI will need to be basically tackled or looked at as part of that overall strategy. And if you're interested to learn more about this, next month I have a handbook coming out to be released soon. So if you're interested, please reach out. Happy to have a chat and help out. So thank you again for the opportunity to present. Over to you, Sarah.
Thank you very much, Hossein, for your wonderful presentation. Thanks. We received a couple of questions. The first question is about machine learning and machine learning models. Machine learning models are great, but much machine learning data is correlational and not necessarily causal and heavily dependent to past behavior. So when we add the rich behavior dimensions of discrete choice models and process heuristics, then we can add a layer of improved behavioral response, which is especially important when we are trying to scale up hot topics such as math. Do you have any comment on that?
Totally agree. I mean, that would be a great application of AI. And as I showed as well, I mean, especially in some of the long tail or edge cases, it is not performing well. They're all data driven, and they are as good as the data that they are being trained on. And as I said, when you have data, those all ethical questions come into consideration as well. This doesn't mean we abandon the way we have been doing things. As I mentioned from the beginning, I think these are additional layers to probably help us solve some of the persistent problems that we haven't been able to solve. If there is no need for AI, that's good, but I see them as having a big impact going into the future, particularly as we start to amass more data. The couple of examples I showed, we had to clean a lot of data in order to arrive at these levels of accuracy. Going forward, this needs to probably be automated. And just judging by the fast pace of developments, I mean, if we give it another 5-10 years, it's just going to be, it's just going to explode and provide more opportunities.
Thank you. The next question is around driverless vehicles. In your view, when do you predict driverless vehicles will be permitted on freeways in Australia? And will this be before arterials, local roads, or gravel roads, or after them?
Yeah. So no one can predict this. I think 5 years ago I was asked, and I said it's probably going to take for full autonomy, not before 2035, 2040, if we get to it at all. Okay, so level 4, as I said, we have it in the US, it's happening. There are issues, there are teething issues, and it will continue to grow. But level 5, door to door, a vehicle can go anywhere under all circumstances. If it happens, that's not going to happen for a very, very long time. I mean, don't misunderstand me. I would like to have them available tomorrow because they will help us reduce the number of crashes, etc. When they are at a level that they are smarter and better than a human driver. The studies we have completed recently, I think we will see autonomous trucks first, probably. We're going to see probably autonomous buses, and we already see examples of this, these small shuttles, before we see them on arterials and motorways. Again, this is putting on the hat that says we need to safety engineer before we do trials on the road, and that's going to take a long time. There was a short video I showed where on mining sites, you don't have a lot of vehicle interactions. The trucks are driving autonomously. I would say probably that is a level 4 because they just go from point A to point B and repeatedly go back and forth. They don't have to park, they don't have to interact with bicycles or motorcycles or vehicles or pedestrians. So that's easier to do off-site. The urban environments are going to be much more challenging. We might see a lot of trials, but widespread deployment is going to take some time.
Thank you. The next question is around AI. To what extent will AI be dependent on other infrastructure, especially communication networks and other infrastructure? And then what will be the risks? I'm not sure whether I got the question correctly. The risk associated with being dependent on other infrastructure?
Yeah, and I think there is a big risk. There is the cybersecurity risk. So absolutely. All of these systems I described are premised on connectivity and are premised on digitalization and automation. So all of that is computerized, and the question, or the person who asked the question, is absolutely right. We all know that computers fail, so you need to have always levels of redundancy. And there are big cybersecurity risks as well. We need a lot of standardization to help overcome this. There were instances a few years back where researchers deliberately infiltrated a connected vehicle through the infotainment system and were able to control the steering wheel, etc., just to prove a point that if the systems are not very well secured, that this could pose problems. So, you can think, I mean, if they fall in the wrong hands and someone wants to do the wrong thing with a vehicle, that could end up being a disastrous situation.
Thank you. Thank you very much for the comprehensive explanation. I cannot see any other question from the audience. Yes. There is no further question. So on behalf of ITE-ANZ, I would like to thank you, Hossein, for joining us in today's session and providing us with your valuable viewpoints and experience. We really enjoyed your presentation. Thank you. And I would like to thank the audience for joining this session, providing us with the questions and having this interactive session. I hope you enjoy your evening and see you in the next events. Thank you.
Thank you. Thank you for the opportunity.